Welcome to this CS320 lecture on regular expressions. Now, from your book, regular expressions is defined right here, and this is on page 36. You'll find the definition of a regular expression. So we're exploring ways to define languages, and so far we have using the dot, dot, dot notation, using a dictionary to list out all of our words, and then we talked about recursive definitions in chapter 3. In this chapter, we're going to come up with a new way to define languages, and it's called regular expressions. And there's just rules to create a regular expression, and it shows you kind of how to generate words that would be in your language and not really say exclude words that are not in your language. Now, one cool thing about this definition, if you look at this definition, it's actually defined using a recursive definition. So the definition of regular expressions is defined using a recursive definition. That means that every valid regular expression is a word in the language of regular expressions, and every invalid regular expression is not. But we're going to use this to define new languages. So let's start with rule 1. It says that any letter, you just make it bold and it becomes a regular expression. Now on this, I can't really write bold letters, so I'll just write a letter. We can try a regular expression. And what this means is the letter A is in the language and no other word is in this language. So that's what that means. We can use the letter B. We can have, and so if this is our regular expression, by the way, this is a regular expression by itself, not combined with this. So this is one regular expression, this is another. So the letter B says the word B is in our language and nothing else. And we can use any other letter, and we can also add the null word in there as a word or as a regular expression as well. So once we have those as regular expressions, then we can go to rule 2 in our rule 2 in our regular expressions. And it has 4 parts. And of course, rule 3 says nothing else is a regular expression. So in part 1, we could just put parentheses around the regular expression. And that really doesn't change the meaning. It just helps us group things later on. Okay? Rule 2 says that we can concatenate any 2 regular expressions together. So I have 3 regular expressions here, but I can concatenate them together and create a new regular expression. So this regular expression here says the word AB is in our language and nothing else. Not just A, not just B. It has to be the word AB. So it's not, oh, I can choose this one, or I can choose this one, or this one. No, it has to be just the word AB, and that is the only word in the language. Okay? Now, rule 3 says that we can do a plus sign in between 2 regular expressions. So I have one regular expression right here. I'll just choose this other regular expression and I'll make a new regular expression, AB plus B. Okay, what this means is in my language, I have the word AB in it. And I also, or I can have the word B in it. So there's 2 words in this language. AB is one and B is another. Okay. Now we have the final rule here is that we can star something. And so we could take any regular expression and star it. So I'm going to, first of all, star this right here, and I'm going to put parentheses around it. I'm going to star my AB. I'm going to put parentheses around it. And now this is a Kleene star. So this language contains the words. Right here, it contains the null word. It has AB, and then we can repeat AB twice. We can repeat AB, AB, AB 3 times, and so on. Okay. Now, let's do a different regular expression. What if I didn't include the parentheses? Okay, in that case, the star only applies to the B. It doesn't apply to this, to the A. So words in this language can be, and now the star means 0 or more, so if 0 B's, we can have just A, or we can have AB, or we can have ABB, and A, B, 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 and so on. If you notice, the star only allows the B to get repeated, not the AB. And finally, we'll do one more regular expression by putting parentheses around A, B, or B right here. And we'll star that. And now we have a choice. So we can include the null word, of course, that's in there. Notice the null word is not in this one. There's no null word in this one because we have to have the A at the beginning. But in this case, right here, there's the null word because we can have 0 of these, or we can have 1 of these. And now the one that we have is up to us. We can choose. We can choose A, B as our choice, or we could have chosen B. Now we can include another one if we want. So we can start off with AB and choose a B to follow that. Or we can start off with AB and add another AB onto that. Or we can start off with AB and then add another AB, and then we can choose again another AB, and then we could choose a B, then we can choose another AB, and then we can just stop. So this star just says 0 or more of whatever it applies to. Without the parentheses, though, it only applies to one letter. Now, there's two tasks that we'll learn in this chapter. And by the way, each chapter kind of learn a new way to define language, not in every chapter, but we're going to learn several ways to define a language. And they're all going to kind of follow this pattern right here. And that is that we need to take a description of a language. So we'll have some sort of description in English, and we'll have to build a regular expression that defines it. That's one task that we'll have to do. Another task will be that we have a regular expression and we have to somehow come out with what the description of that language. We'll be able to clearly state what words are in the language and what words are not. So let's go ahead and start off with a regular expression and see if we can figure out what it means. So we'll start off with A or B star. Put the letter A, and then we'll put another A or B star after it. So what does this regular expression mean? Well, we can have 0 or more A's and B's. Then we have to have one A because there's no star around this. That means that we have to have one A. Then we can have 0 or more A's and B's afterward. So let's go ahead and write out some words. Maybe we can go A, B, B, A. And this was generated by this. We decided that we'll do this or get 4 of these. We chose A as the first one, 2 B's, and then another A. So that got generated from that. And then we have to have the A come down. And finally, we can add as many A's and B's onto the end of it as we want. So we can just go B, B, A, B, A, or something like that. Okay, so this is one word in this language defined by this regular expression. So this is a regular expression, and we're able to generate one word that is in the language. So what does this language mean? Well, when we got this A, B star, that means we can generate any string. It could be the null word. It can be any number of A's and B's in any order. So that's any word followed by at least one A, and then any word after it. So the description of this language would be all words that contain at least one A. Now let's figure out if we can know what this regular expression is. So we got A or B star. A or B star, and then we're going to say or B. So what is this language right here? Well, we can have, if you notice, this part right here is the same as that one. So that's all words that contain at least one A. What's this right here? Well, that's just the word B, only B. And if we put a star on this now we have all words that contain at least one A and all words that don't have any A's. Notice this can have more than one A. So really, what is this language? Well, it's all words that we could possibly come up with. By the way, it's a lot easier if we just put A or B star. But these two regular expressions are exactly the same thing. Now let's try to do this first task where we start with a description of a language and we try to generate a regular expression. So here's our description of our language, all words that contain at least two A's. So how might we do that? Well, if we know that we want a letter to be in it, we can just write that letter down. And now we know that we want two of them. Now it doesn't matter where the A's are, so we could put any word we want before it, between the two, and after it. So all we have to do is add A or B star in front of it, A or B star in between it, and an A or B star after it. And now we have the regular expression of all words that contain at least two A's. Now let's try to see if we can figure out what this regular expression defines. So we've started off with some really easy examples, and now we got pretty complex. And this could be really hard to figure out what it is, but what we can do, maybe a strategy, is to take each half of this one at a time and see what it is. So in this case right here, we have A or B, so we have any word, followed by one of these, and then another any word. So what is one of these? Well, it's a double letter, two A's in a row or two B's in a row. Okay, so this part right here is any word with a double letter in it. So it can come up with some examples: A, B, B, A, and then we have, we'll choose two B's to be that, and then A, B, A, B. Okay, so this part was generated by that. This guy comes down there, and then this generates the AB. So if you notice, there's a double letter up here. And we didn't say that it can only have one double letter. We just said that it contains at least one double letter. So here's the at least one. This other one was generated by that. Okay. So this part right here is all words that contain a double letter. If we keep looking at this part right here, we can start with a B or not. So if our word starts with an A, we just skip over this, right? And then that's the same with the ending. We can end with an A or not. So if we want our word to end with a B, we're just going to end with one of these. So what does this mean right here? Well, that means that we can just keep repeating A's and B's as much as we want. And then if we want to put an A on the end or a B at the beginning, we can. But when we do this, this forces us to never, ever get a double letter. So these are all words with at least one double letter, and these are all words without any double letter in them at all. So when we combine them together, what do we get? We get all possible words. So we can tell that maybe regular expressions aren't quite as easy to just look at this and say, oh, that's all words, right? We had to do quite a bit of analysis and figuring out to figure out that this regular expression was really equal to this regular expression. Okay, let's end with one last hard to figure out regular expression. What does this regular expression mean? And it could take quite a lot. If you can figure out on your own, then congratulations. This is definitely really hard to try to figure out what it means, but let's go through it. By the way, we're using some square brackets here, and that just the same thing as parentheses, but that just helps us match our parentheses up. So that way we can tell that these are all different um, things, and then they're grouped by these square brackets. So we can have 0 or more of double A's, double B's, or whatever this thing is right here. So let's go ahead. We can get a couple of double A's or double B's in our word, okay? But at one point, if we pick this as our term to repeat, then what we have to do is we have to include one of these and one of these, okay? So let's go ahead and include, I'll choose a BA here and an AB here. So this went there and that went there, okay? So what can we put in between here? Well, double A's or double B's, so okay, so really, what does this all mean? Now, after we do that, we can go back and we can choose some more double A's or double B's, or we could choose another one of these guys. So if we always are adding two A's, then the number of A's we have is even. If we're always adding two B's, then the number of B's that we have are even. So if we count up all the A's in this string, well, in this part right here, we know that our A's will be even. And we also know that our B's will be even. But what happens when we choose this part right here? Well, now we got an odd number of A's and an odd number of B's. So now instead of having an even number of A's and B's, we're at an odd, okay? But this right here is going to put us back in balance or back into the even column. So since we require one of these to go odd and require another one of these to go back to even, no matter what we choose, we're always going to add two A's and then two B's. If we go to odd, we're going to be forced to correct ourselves back to even later on. So the book calls this language even, even, meaning we have an even number of A's and an even number of B's.